Okay, the first question in the kinetics handout, which you can find in the folder on Blackboard, labeled as selected lecture material and practice problems, is a true or false question. And it says, if increasing the concentration of A in a chemical reaction causes no increase in the rate of the reaction, then we can say that the reaction rate is first order in A. Well, if a reaction were first order in A, and if A were the only reactant, I would write that rate law expression as being equal to a rate law constant K times my reactant A, and that would be raised to the power of 1. And when that is the case, we don't usually write that number 1, but we'll just put it here to show. So it says if I increase the value of A, the concentration of A, I do not get an increase in the rate if it's first order. Well, that's very definitely false, because we can see from this equation that the rate being first order in A, if I increase this concentration, I should very definitely have an increase in the rate. So number 1 is false. Let's try number 2. See if we can do 2 questions per video here, so they don't end up being very long. Number 2 says if the rate of a specific chemical reaction is independent of the concentrations of the reactants, the reaction is zero order. Let's use for our example, again, the simple case where we have a single reactant going to a product. And it says that the rate is independent of the concentrations. Well, we know that that could only be the case if the reaction is zero order in A, and therefore the reaction is zero order overall in this case. And so number 2 is true. And the reason why it's true is because any number raised to the power of 0 is equal to 1. And so I could change A all I like, but because it's raised to the power of 0, it has no effect numerically on the value of the rate. So number 2 is true.